This chart comes from the PYPL index, which analyzes how often people search for programming tutorials on Google. The idea is that the more a language is searched, the more popular it likely is. Currently, Python leads by a wide margin, showing its dominance in areas like data science, AI, and general software development. Java remains strong, especially in enterprise systems, while JavaScript continues to be essential for web development. Other languages like C Sharp, C/C++, and PHP maintain steady use, though their growth trends vary. The PYPL index helps us understand not just what's popular today, but also where industry demand and developer interest are heading. Today, we're starting with one of the most important building blocks of programming: variables. By the end of this lecture, you'll understand what variables are, how to use them, and why they form the foundation of every program you'll ever write. We'll also look at why writing clean, readable code is just as important as making code that works. When we begin programming, the very first concept we learn is variables. A computer's job is simple. It stores information, processes that information, and then modifies or produces new information. And notice, the very first step is storing. Without variables, we have no way to store anything. Variables act like containers that can hold numbers, words, or other kinds of data. Once the information is stored, we can process it and use it to generate results. That's why variables form the foundation of all programming. In technical terms, a variable is a named storage location in the computer's memory that holds a value. This value can be changed during the execution of a program, hence the name variable. Variables are essential in programming because they make working with data possible and manageable. First, they let us store data, keeping numbers, text, or other values in memory. Second, they let us refer to data by name, so we don't have to remember or retype the actual value. Third, we can modify data inside variables, which means values can change as our program runs. And finally, variables let us reuse data, since we can reference the same stored value as many times as we need. Together, these abilities make variables one of the most fundamental tools in programming. Let's connect three core concepts in programming: variables, statements, and expressions. A variable is linked to a memory location in the computer. Its value can change as the program runs. A statement is a complete instruction, something you design to perform a task or action. For example, assigning a value to a variable is a statement. An expression is anything that results in a value. It could be as simple as the number 5 or as complex as x plus y times 2. Every expression, when executed, ends up producing a value. Together, variables store the data, expressions produce values, and statements use both to make the program actually do something. In programming, we work with variables by declaring them and assigning values. Declaring a variable means introducing it and giving it a name. Assigning means giving that variable a value to hold. In some languages, these are two separate steps. You declare first, then assign later. But in Python, both steps usually happen together. For example, writing x equals 10 declares a variable named x and assigns it the value 10. From that point on, we can use x in calculations, update its value, or print it out. This process of declaration and assignment is the first step in making programs actually work with data. In programming, the symbol equals does not mean equality like in math. Instead, it means assignment. When we write y equals 22, it means we're assigning the value 22 to the variable named y. When we write x equals 1 plus 3, the computer first evaluates the expression 1 plus 3 to get 4, and then assigns that value to x. Similarly, z equals 3 minus 3 evaluates to 0, which is stored in z. Always remember, the variable name goes on the left-hand side of the equal sign, and the value or expression goes on the right-hand side. The left-hand side represents a memory location. It's like a home address. The right-hand side represents the value to be stored. For example, x equals 2 plus 3 means calculate 2 plus 3, then put the result into the memory location labeled x. When variables appear on the right-hand side, they refer to the value stored in that memory location. But if you try to put something like x plus z on the left-hand side, it won't work. You can't add two addresses together, just like you can't add your home address to mine. Think of addresses like street addresses. You can't just add two of them together and expect it to make sense. Even in a case like y equals y, the two y's mean different things. The left y means the memory location. The right y means the value stored there. So when we write y equals y plus 1, it means take the current value of y, add 1, and then store the new value back into the memory location called y, replacing the old one. Similarly, x equals z plus y means take the current values of z and y, add them together, and store the result in the memory location labeled x. A variable name such as x is called an identifier. Identifiers can include letters, digits, and underscores, but they cannot start with a digit. For example, score 1 is fine, but 1 score is not allowed. Python is also case sensitive, which means lowercase x and uppercase x would be treated as two different variables. So when naming variables, it's important to follow these rules carefully to avoid errors in your code. Here are some examples of variable names in Python. On the left side, we see valid identifiers. Score 1 is valid because it uses letters and numbers and starts with a letter. Total score is valid because underscores are allowed. Age is valid because it's just letters. On the right side, we see invalid identifiers. 1 score is not valid because variable names can't start with a digit. Total score is not valid because dashes are not allowed in identifiers. And notice age versus age. In Python, those would be treated as two different variables because Python is case sensitive. So remember, variable names must follow the rules, and clear naming makes your programs easier to understand. Coding conventions are basically the formatting standards that developers agree to use when writing code. They're not about changing how the program runs. The computer doesn't care about spaces or style. Instead, conventions are about making code easier for humans to read. When everyone follows the same style, it simplifies understanding. You don't have to waste mental energy figuring out why one piece of code looks different from another. The goal is to minimize the load on memory, thinking, and even vision when reading programs. Clean and consistent code helps teams work together more smoothly and prevents mistakes. In Python, variable names should follow the PEP8 style guide, which is the official coding convention for Python developers. The rule is simple: use all lowercase letters. If your variable name has multiple words, separate them with underscores. This is called snake case. For example, sample underscore variable underscore name is a proper variable name according to PEP8. Why is this important? Because when all developers use the same style, the code looks uniform and is much easier to read. It prevents confusion, reduces errors, and makes it easier for teams to collaborate. Even if you're working alone, following conventions makes your code more professional and easier to maintain later. Python provides several arithmetic operators for performing calculations. The plus sign is used for addition. 5 plus 3 gives 8. The minus sign is subtraction. 5 minus 3 equals 2. The asterisk is multiplication. 5 times 3 equals 15. The forward slash is normal division. 5 divided by 2 gives 2.5. Double slashes mean floor division, which gives only the whole number result. So 5 double slash 2 is 2. The percent sign, often read as mod, gives the remainder. For example, 5 mod 2 equals 1. And finally, double asterisks mean exponentiation. 2 double asterisks, 3 equals 8. These operators are the basic building blocks for math in Python, and you'll use them constantly in your programs. When Python evaluates expressions, it follows a strict order of operations, just like in math. Parentheses come first. Anything inside parentheses is calculated before everything else. Next comes exponentiation. Unlike most operators, exponentiation works right to left. Then come multiplication, division, and modulus. These are evaluated left to right in the order they appear. Finally, addition and subtraction are evaluated last, also left to right. So when you write complex expressions, Python always applies this hierarchy unless you override it with parentheses. In Python, there are 3 main categories of errors you'll encounter. Syntax errors happen when you break Python's grammar rules. For example, forgetting a colon or misspelling a keyword. Python will usually point these out right away, making them the easiest to find and fix. Runtime errors, also called exceptions, occur while the program is running. For example, dividing by zero or trying to use a variable before it's defined. These cause the program to crash. Logic errors are the trickiest. The program runs without crashing, but it produces the wrong output because your logic is flawed. For example, using the wrong formula or mixing up variables. Logic errors are the hardest to catch because Python won't warn you. The code runs fine, but the result is wrong. You have to carefully test and reason about your code to find them. On the other hand, syntax errors are the easiest to fix because Python gives you an error message pointing to the problem. One of the most important habits in programming is writing readable code. Readable code is easier to understand, easier to debug when something goes wrong, and easier to maintain over time, both for you and for others who may read your code later. Take a look at our example. While it works, there are two main issues. The variables use single characters, A, O, and T. These don't describe what the values actually represent. If this were part of a larger program, it would be very confusing. The code doesn't use spaces around operators. According to Python's style guide, PEP8, we should add spaces to improve readability. A better version would be this. Now the code is much clearer. You can immediately tell what's happening. However, there's still a small issue. Line 2 does not leave a space after the equal sign. According to Python's coding convention, PEP8, we should include a space after equal sign for consistency and readability. So this is the way the code should be written. When writing code, there's often a question, should I make it easy to read or should I make it run as fast as possible? The truth is, readability is almost always more important. Software development is rarely a solo activity. You're usually working with teammates, or your code will be maintained by others in the future. If your code is hard to read, it becomes a liability. Also, modern compilers and interpreters already do a lot of automatic optimization behind the scenes. That means in many cases, writing clever but unreadable code doesn't actually make things faster. That said, there are rare situations where performance must come first, for example in embedded systems or resource-limited environments where every cycle and every byte counts. But in general, readability and performance are not opposites. With good coding practices, you can often achieve both. Code that is clear to read and runs efficiently. To wrap up, remember this important idea from Martin Fowler, a well-known software engineer. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. This really captures what we've been discussing today. Computers will run almost anything you write, as long as it's syntactically correct. But great programmers go further. They write code that other people can read, understand, and maintain. So as you learn and practice, don't just aim for code that works. Aim for code that's also clear, clean, and readable. Thank you. This presentation was prepared by June Lee with the assistance of AI technology.